Hi there. So today we are going to start a new topic, a new series basically, a new series of IGCSE Cambridge for the paper 0580, the extended version. So first topic that we would be doing is recurring decimals. Okay. So first of all, what do you mean by recurring decimals? We know that recurring decimals are those numbers or the decimal forms where the decimal portion is getting repeated again and again in a particular pattern. For example, 0.7777, the 7 is going on. So you can write it down as 0.7, a small dot above 7. And some notations we use a small bar as well. Okay, so both actually means you are using a recurring decimal, and for IGCSE this is the standard notation. And suppose I'm writing 0.232323, so this can be noted as 0.23, which means 2 and 3 is getting repeated again and again. So now suppose I'm having 0.1252525, it's going on like this. So here you can see that 1 is not repeating again and again, it's just the 2 and 5 getting repeated. So you can write it down as 0.125 having the dots above. So here you have to know the concept that recurring decimals are literally rational numbers. And what was a rational number? A rational number was a number which can be converted or written in a fraction form, in the form of a over b, where b is not 0, okay, and a and b are integers, okay. Any number which can be written in the form of, I'm sorry for the spelling mistake, any number which can be written in the form of a over b, where b is non-zero and a and b are integers, is called a rational number. So here any recurring decimal can be converted into this fraction form. So let's see how do we convert them into these fraction forms. So first of all, we know that, for example, if I'm having a terminating decimal, a decimal which is not repeating, for example 0.25, just 0.25, I know how to convert it into a a fraction form. You can make it into 25 over 100. Because you have to having two places, so you will write it down as 25 over 100 and then further do the simplification process. You can see that 25 goes in 25 one time and 25 goes in 100 4 times. So the simplified version of this is 1/4. Same way you can do 0.1. 0.1 can be converted as 1 over 10 because you have only one decimal place there. And 1 over 10 for the simplification is not possible. So every terminating decimals can be converted into rational numbers, into fraction forms. Okay, so terminating decimals and recurring decimals will come under rational numbers. So now let's see the main part of the video, that is how do we convert the recurring decimals to rational numbers. So the very first question we are doing is convert 0.7 with recurring to a fraction form. So here you can see the very first step, we have a procedure for this. So the very first step is to write down x is equal to 0.7 with the dot. Okay, so now our aim is to make another equation from the same thing where we have the same recurring part as the decimal part. Okay, so here we have x is equal to 0.7 dot. So now we'll multiply this with a 10. So 0.7 dot means what? It's 0.777 is getting repeated. Now if I'm multiplying this with a 10, the point will move one place to the right side and it would become 7.777, which is literally 7.7 dot. So I will multiply with a 10 on both sides. So I will get 10x this side and 7.7 dot the other side. Now you can see that both these parts have the same recurring part. So you can actually subtract them directly. Okay, so 10x minus x would give me 9x, and 7.7 dot minus 0.7 dot gives me just 7, because the decimal parts will get crossed off directly and you're just subtracting the whole parts, so it'll be just 7. So you can just solve for x there. X is equal to 7 over 9. So we started with x is equal to 0.7 repeating, and we saw that x is 7 over 9, which means 7 over 9 is the fraction form of this recurring or repeating decimal. I hope it's clear. So let's do a second question. So here you can see two parts are repeating, right? So we have to make sure that we always have the same repeating part in all the steps. So well, let's first write down x is equal to 0.23 with 2 and 3 repeating again and again. So the very first step is multiplying with a 10. 10x is equal to 2.32. It will be like 0.23. 2323, it's going like this. So when I'm multiplying with a 10, the place will be just one ahead, so it will be 2.32 repeating again. You can see that this will be 32 32 32 going on, so I can write it as 32 repeating. But you can see here there's a mismatch. The decimal parts are not matching each other, so we will have to get a step where both the recurring decimal parts are matching up. So I would make it 100x. So 100x means the point will move once again to the right side. So it'll be 23.23 with repeating part. Now you can see that these two parts actually match up there. Okay, so what you can do there, we can get rid of this step. We don't need this step in between. You can directly multiply it with 100 so that the decimal recurring part is the same. So you can do 100x minus x, which will give me a 99x, and this side these two will get crossed off easily. You will just get 23. So x would be 23 over 99. Further simplification here is not possible. So the fraction form of the recurring decimal 0.23 repeating would be 23 over 99. So now let's do one more. So here you can see that here it's a little bit different. You can see that there is no dot above 5, which means 5 is not repeating again and again. It's just 0.5343434. It's going like this. Okay, so let's do the first step. It's always writing x. X is equal to 0.534. Okay, so now if I multiply with a 10, I would get 5.34 repeating. Okay, but you can see the decimal parts are not matching. Okay, so now you will do 100x. 100x would give me 53.43 repeating. These two parts are also not matching. First of all, remember, you cannot take up this x step in any of the subtraction process because you have a non-repeating part there. We're trying to bring down only the repeating part. We'll take only the steps where the decimal part is just the repeating part. Okay, so here you can multiply again with the 10, which will make it 1000x. So this will again become 534.34 repeating. So now you can see these two steps. See, both the decimal parts are getting matched up. So 1000x minus 10x will make it 990x. Okay, so I'm using these two steps. You can get rid of the middle one. So 1000x minus 10x will make it a 990x, and here you can get rid of the decimal parts, and you're just subtracting 534 and 5. So that would give me 534 minus 5 is going to give me a 529. So that would be 529 here. So x would be 529 over a 990. So that will be the fraction form of your repeating decimal for this part. And let's do one more. So convert 1.23, where 3 is repeating, to a fraction form. So let's call x is equal to 1.23. As you know, we have to make the repeating part alone. Okay, we need to get two steps where the repeating part is alone in the decimal portion. So first we'll multiply with the 10. So 10x will give me 12.3 repeating. See, this is one step which we can consider. Now 100x, that will be 123.3 repeating. See, both have the same repeating part. So you can take 100x and 10x. There is no need of taking the x there. It will make it more complicated. So go with this. 100x minus 10x will give me 90x, and this would give me 121. So x would be 121 over 90. So that is going to be your fraction form. I hope that's clear, and I have attached 2 questions over here. You can make a try on them and comment the answers below. Thank you. We'll see you with a new topic next week.